Hello everyone, myself Priyanka H. Kudigar. I'm studying in first year MSc Chemistry. Now I am going to discuss about periodic table. Periodic table may be defined as the tabular arrangement of the elements in such a way that the elements having same properties are kept together. Dmitry Mendeleev in 1800 proposed the table for 70 elements based on increasing mass and similar properties. And another scientist, Henry Moseley, in 1913 determined the atomic number of elements are arranged the table in order of increasing atomic number. This is the periodic table of elements in which elements are colored differently, in which this green colored elements which denotes the non-metals, and this yellow color metals are denotes the alkali metals, in which this blue color elements are denotes the transition metals, and this light blue color elements are determines the alkali earth metals, and this blue color elements determines the earth metals, and this purple color elements determines the other metals, and this light yellow color elements determines the halogens, and these pink color elements determines the inert elements. Classification of elements. The arranging of elements into different groups on the basis of the similarities in their properties is called as classification of elements. The classification of similar elements into groups makes the study of elements easier. There are about 114 different elements known so far. Now, let us discuss about the Dobrynin's traits law. First attempt towards the classification of elements was made by John V. Dobrynin in 1871. He arranged elements in the group of 3 and in such a way that the atomic weight of middle element was equal or nearly equal to the average of atomic weights of other 2 elements. 3 elements each, he called these groups traits. In each of traits, the atomic weight of the middle element was equal to the average of the atomic weight of the first and third elements. In this tabular column, and this is the element, and this is the atomic mass of these elements, and this is the mean of first and third element. The drawback of this is only limited traits were arranged in this pattern. Now let us come to the Newland's law of octaves. The English chemist John Alexander Newland in 1865 propounded law of octaves. It states that when elements are arranged in order of increasing order of atomic mass, the properties of every 8th element starting from any element are a repetition of the properties of the starting element. And the limitations was it was only up to calcium that the classification of elements done. Now let us come to the Mendeleev periodic table. In 1869, Mendeleev arranged 63 elements in rows or columns in order of their atomic weight. Periodic law, the properties of the elements are periodic function of their atomic weights. The vertical rows were called groups, while horizontal rows were called as periods. There were 9 groups. Group 8 has 9 elements which were arranged in traits. 0 group had noble gases with 0 valency, and there were 7 periods in Mendeleev periodic table. Modern periodic table. Physicist Henry Moseley that the atomic number of the element is its more fundamental property than its atomic mass. So accordingly, the periodic law was also changed. Modern periodic law states that the properties of the elements are periodic functions of their atomic numbers. Elements were rearranged in the periodic table according to the modern periodic law. Thus, the modern periodic table was formed. Presently, modern periodic table or long form of periodic table is widely used by chemists. It helps in the study of physical and chemical properties of elements. In modern periodic table, elements have been arranged according to their increasing atomic numbers, and in modern periodic table, it has 18 groups and 7 periods. And the elements of the same group have a similar outer electronic configuration. The period number corresponds to the highest principal quantum number, that is n, of the element in the period. In the modern periodic table, 14 elements of both the 6th and 7th period are placed in the separate panels at the bottom. They are known as lanthanides and actinides respectively. Now let us come to the classification of elements on modern periodic table. The modern periodic table consists of 18 vertical columns called the groups, that is from 1 to 18, and 7 horizontal rows called periods. Then the first period contains 2 elements, that is hydrogen and helium. The second period contains 8 elements, that is lithium to neon. And the third period contains 8 elements, that is from sodium to argon. Then the fourth period contains 18 elements, potassium to krypton. Then the fifth period contains 18 elements, that is from rubidium to xenon. The sixth period contains 32 elements, and finally the seventh period is incomplete. According to the modern periodic table, these are the classification of elements on modern periodic table. On the basis of electronic configuration, elements are classified into 4 blocks known as S block elements, P block elements, D block elements, and F block elements. The first and second group elements are known as S block elements, whereas 13 to 18th group elements are known as P block elements, whereas 30 to 12th group elements are called D block elements. And the lanthanides and actinides elements are called as F block elements in the periodic table. The general electronic configuration of S block, P block, and D and F block elements are, whereas X block elements have general outer electronic configuration, that is NS1-2, where N is equals to 2-7, whereas P block elements have general outer electronic configuration, that is NS2 NP1-6, where N is equals to 2-6. Whereas D block elements have general outer electronic configuration, that is N-1 D to the power of 1-10 NS0-2, where N is equals to 4-7. And finally, the F block elements have general outer electronic configuration, that is N-2, the F 1-14, N-1D 1-10, and NS2 when N is equals to 6-7. Now, let us know about the periodic groups. Periodic groups are alkali metals, and they are alkali earth metals, and they have transition metals, and they also have lanthanides, actinides, and halogens and noble gases. And the alkali metals, group 1 in periodic tables are known as alkali metals. They are soft solids and they are very reactive. They have tendency to lose electrons, and they readily combine with halogens. For example, sodium, potassium, etc. Then let us come to the metals. Metals are the elements that are usually solid at room temperature, and they have high electric conductivity, and they are ductile and malleable. And they are on the left side of the periodic table, that is except hydrogen. Then alkali earth metals, They are the group 2 periodic table. They can be seen in the group 2 of periodic table, and they are not as reactive as alkali metals. They are the abundant metals in the earth, for example, magnesium and strontium, and they have high density and melting point than alkali metals. And non-metals, in the upper right corner of the periodic table, we can see non-metals on the upper right corner of the periodic table, and they are non-lustrous, and they have poor conductors of electricity, and some oxygen and chlorine gases at room temperatures, and they are brittle solids. Halogens. Halogens are the group 17 elements in the periodic table. It forms ionic bond and combine with group 1 and 2 to form salts. Example, chlorine, bromine, etc. Now let us come to the noble gases element. Group 18 in the periodic table. These elements are known as noble gases element. They are gases at room temperature, and they are inert or non-reactive. Example for noble gases elements are xenon, argon, etc. Each element have different colors such as orange to red, pale to lavender, and pale peach, etc. This is about the noble gases elements. Now let us come to the transition metals. Group 3 to 12 in periodic table are known as transition metals. They are important for living organisms as well as minerals. So the examples for transition metals are iron, zinc, etc. Here we can see inner transition metals in a chart. Lanthanides. It is a part of inner transition metals. Elements from 57 to 70 in the periodic tables are known as lanthanides. They are soft silvery metals. For example, cerium, europium, etc. Now, actinides. Actinides are the part of the inner transition metals. Elements from 89 to 102 in periodic table are actinides, and they are radioactive elements. For example, uranium, plutonium, etc. Now let us discuss about periodic properties and their trends. Properties of the elements which are directly or indirectly related to electronic configuration of their atom and show gradation in moving down a group or a longer period. The common physical properties were, first one is atomic radius. Atomic radius is the distance between the center of the nucleus and the outermost shell of the electron in an atom or ion. Next, ionization energy. The energy required to remove outer electrons and results in the formation of positive ions. This is about ionization energy. Then electron affinity. The amount of energy released when an isolated gaseous atom accepts an electron to form monovalent gases, that is electron affinity. Then electronegativity, the tendency for an atom of the given chemical element to attract shared electrons when forming the chemical bond. This is known as electronegativity. Now let us discuss about the elements in the periodic table. That is, first one is S block elements. The S block elements are elements of group 1 and 2, and the general electronic configuration of S block elements is Ns1-2, and these S block elements are soft metals with a low boiling point, and low ionization enthalpy and highly electropositive metal. These S block elements are highly electropositive metals and they having low ionization enthalpy with a low boiling point, and they impart color to the flame. This is about the S block element. Now let us see what is P block elements. P block elements, that is the elements from group 13 to 18 constitutive P block. These are the P block elements. The general electronic configuration is NS2 NP1-6. These P block elements form covalent bond, and these P block elements includes metals and non-metals, and the reducing nature increases from top to bottom, and oxidizing nature is this oxidizing nature, it increases in a period from left to right. These P block elements in reducing nature, it increases from top to bottom, and in these P block elements in oxidizing nature, it increases in a period from left to right. And these P block elements are normal or representative elements. Then D block elements. Elements from 3 to 12 are known as D block elements. The general electronic configuration is N-1D 1-10 and NS1-2 N-1 and D1-10 NS1-2. This is the electronic configuration for D block elements, and these D block elements are the hard metals with high melting point, and these are the good conductor with heat and electricity, and the oxidation states are variable in D block elements. And these D block elements have both ionic and covalent compounds, and these D block elements act catalyst, that is manganese, iron, cobalt, nickel form alloys. Now let us come to the F block elements. The element's last electronic enters the F orbital of N-2 shell is a F block elements. Two series, that is 4F and 5F to 14 elements are the F block elements, and these are known as rare earth metals. The general electronic configuration is N-2, that is F1-14, and N-1, that is D0 to 1, and NS2 N-2 F1-14 and N-1 D0-1 and NS2. This is the general electronic configuration of F block element. Lanthanides and actinides, that is from 6th to 7th period and third group. This is also called as inner transition elements. And these F block elements are the heavy metals and have variable oxidation states, and these are radioactive in the nature. This is about the F block elements. And this is all about the S, P, D and F block elements in the periodic table. This is my reference. Thank you.